In this example, we want to evaluate log base 18 of 9 plus log base 18 of 2. So we're going to use the properties of logarithms that we saw earlier to evaluate this. So first, we see that we have a sum here and that both of these logs have the same base. So we can use the product property and kind of go backwards and put this together into a single log. So we can say this will become log base 18, and then 9 and 2 will be multiplied, 9 times 2. And then just simplifying, we get that this is log base 18 of 18. And if you recall, whenever you have a log where the base and the argument are the same, it's equal to just the power of your argument. And so the exponent for our argument is a 1. So log base 18 of 18, this whole thing is equal to 1. And so this entire expression is just 1. In this example, we want to take this log base 6 of 36x, and write it as a sum or difference. And it says to express any powers that we have as factors. So they want us to use the power rule. So first, I see that this is a composite, so it's 36 times x, which means we can use the product rule to break this up. So log base 6 of 36 times x can be broken up into log base 6 of 36 plus log base 6 of x, just using the product rule. And then we can express 36 as 6 squared. So we can go ahead and do that. This can just be expressed as 6 squared because they want us to express powers as factors. So now we have log base 6 of 6 squared plus log base 6 of x. And what that does for us is it allows us to use the power property, which says we can take this 2 and move it in front of our log and express it as a factor. So we end up with something like this. So it's going to be 2 times this log base 6 of 6 plus log base 6 of x. And then we have the identity property. The identity property tells us when you have a log with this, where the base of your log is the same as the base of your argument, it's just equal to its power. So the power here of 6 is 1. So this whole thing right here is actually just equal to 1. So we can kind of simplify this a little bit, and we end up with 2 times 1, which is just 2, and then plus log base 6 of x. So this is an equivalent form of this. In this example, we want to take this log and express it as a sum and or difference. And then again, it's asking us to express powers as factors. So the log here, its base is 10. So we have, looks like there's a lot going on in here. We have a product in our numerator. We have a quotient here. So that tells me we're probably going to have to use the difference property, the product property, power property looks like it's going to have to come into play as well. So first let's do the difference. Let's break this quotient up into a difference. So this is log of, so the numerator becomes the first value in our difference. So it's x minus x plus 7, this quantity, and then minus the log of our denominator, x plus 5 to the 16th. So again, now we have a product in this first log, which means we can break this log up using the product property. So this here, that can be broken up into the sum of two logs. So we get log of x and then plus log of x plus 7, the quantity x plus 7. And then this quotient still exists, and we can actually just take care of this power here. This power can be moved to the front right? The exponent can be moved to the front using the power property. So it's going to be minus 16 times log of the quantity x plus 5. And that's it. That's this expression expanded and written as a sum or difference of different logs. And then again, we expressed the powers as factors.